Okay, here's our lesson 8.2 on graphing rational functions. This lesson is not going to talk about using transformations, but it's going to talk about some other aspects of rational functions. We are going to talk some more about asymptotes. So the first note that you need to take down is that because rational functions are fractions, the denominator cannot equal 0. So we call any number that causes the denominator to be 0, we think about these as excluded values. I spelled that wrong, EXC, excluded values. And excluded values can do two things, so just kind of look for these. They can cause holes in the graph, which would be, you've probably seen these in problems before where you have like the graph and then there's a hole and then it keeps going. Or you can have asymptotes, which we just learned about last week. And asymptotes, remember, are where your graph, it looks like it's going to go forever, but it's never going to actually touch that line. So just notice the difference between holes and asymptotes. So let's look at a few different functions and kind of see the difference and how we notice they show up. Okay, so if we look at some examples, we're just going to look at a few different problems and just kind of make some notes about them. So my first one, remember, we look at our denominator to find our excluded values. So if the whole denominator cannot equal 1, think about this as a factor all on its own. I'm sorry, cannot equal 0. Think about that as a factor all on its own. So we want to think opposite, which means positive 1 is the excluded value. So I'm going to write down that my excluded value is x. I just write that as x cannot equal 1. All right, if I go through and do the same thing for these other problems, on the next one I have x cannot equal -1. On the third one, x cannot equal -1 or +4. Notice that I'm only looking in the denominator here. I'm not paying any attention to the numerator right now. And on the last one, I just want you to make a note that you would need to factor first. And then we're going to work the last one together here in just a minute. Okay, so now that we've made a note of what the excluded values are, we need to figure out when it's going to be a whole and when it's going to be a vertical asymptote. So I'm going to take a minute to write the notes, and I want you to see if you can figure out any type of pattern. All right, my first one is going to be an asymptote. In the second one, it's going to be a hole. And the third one's going to have two patterns. The +1 is going to be an asymptote. And the 4 is going to be a hole. All right, so see if you can pause the video and see if you can notice any patterns there. Hopefully what you noticed are maybe some things in the equation. So notice the holes are happening when you have the same thing on the top and the bottom. If you remember any of this from freshman year, from Algebra 1, you should have noted that, or remember that these things are going to cancel. So anytime you have factors that cancel, that creates a hole. You may want to pause and write that down. And the last thing we want to take a note of, so we've noted that these things are going to cancel out. The last thing we want to take a note of is if there's anything left on the top, that's going to cause us to actually have something else which is called a slant asymptote. So, and that's, maybe didn't say that very well. I guess what I mean is if the top is bigger than the bottom. So in this second one, for example, because the top has a bigger degree, it has more x's, then it is going to have a slant asymptote. So this is going to have a slant asymptote, and we're going to get that, to get our slant asymptote, we're going to have to divide, and we'll talk about how to do that here in a minute. None of the others are going to have a slant asymptote because none of these other problems, even the bottom one included, have numerators that have a higher degree than the denominators. So just kind of keep that somewhere in the back of your mind. So from this slide, the two things you need to have really, you need to know that you're going to have to factor first if it isn't already, and then you should be able to tell the difference between an asymptote and a hole based on excluded values. Okay, so I told you that we're going to need to factor first, and actually I'm going to show you kind of a different way to think about this. You all might like this better. So you should note on the bottom that we've got an excluded value here. So just note that this is excluded value. My excluded value is going to be x cannot equal -3. Now, I need to know if that's a whole or an asymptote. And to do that, I could factor the top, but remember from the last chapter last week we learned if we do division and we get a 0 at the end, then it is a factor, and that will give us the factor. If not, it's going to already be a shortcut to figuring out maybe any other asymptotes that we have. So I'm going to go ahead and copy down my numbers, 1, 1, -2. I'm going to work this out real quick. Remember, add and multiply, so this is -2, that's +6, which is 4. Okay, so notice, this right here means that it is not a factor. Not a factor. And I also want to make a note that that means, so just kind of follow my train of thought. It's not a factor, so it does not divide, which also means it's not going to cancel. So if it doesn't cancel out, think back to what we just said. That means that my excluded value up here is going to be an asymptote and not a whole. If it had canceled, it would have been a whole. So now let's remember, this right here I can write as a polynomial, so that's x to the 0, x to the 1, which means I've got this 1x minus 2. Now this is the new note that you need to take. When you divide, the polynomial that you have left is an equation. This is an equation for a slant asymptote. All right, that means my slant asymptote is like it's a line. Y equals 1x minus 2. So you can just watch what I'm about to do. I just kind of want to show you what this is going to look like on the graph. So if I draw myself just a rough little graph, I know I'm going to have an asymptote. Let me fix that. An asymptote at -3. 1, 2, 3. So I'm going to have an asymptote that looks like this. Pretend that goes through where it's supposed to. And then I'm going to plot my line y equals 1x minus 2. So -2 up 1 over 1, up 1 over 1. So I'm going to have another asymptote that runs this way. This is going to look kind of funky. All right, that means my graph, remember it starts in this corner, like up 1 over 1. And my graph is going to look like this and like this. So just kind of keep that in mind. That's what that slant asymptote is going to look like. All right. Okay, this last one looks a little bit different. Because the bottom is not factored, now I do have to factor first. So I want to factor this out. Remember, that means I'm looking for two numbers that multiply to give me -4. And I want them to add to give me +3. And those two numbers are going to be +4 and -1. +4 and -1, which means my problem when I rewrite it is going to be x plus 1 on the top. I'm just bringing that down. And on the bottom, I'm going to have x plus 4 and x minus 1. Okay, so we're going to look at our excluded values. So at the bottom, if we consider these, this is going to be x cannot equal -4. The next one's going to be x cannot equal +1. And because none of that is canceling with the factor that's on the top, these are both going to be asymptote type excluded values. I am not spelling that right. Fix that, asymptote. Okay, so we're not going to graph that. These are going to start getting a little more complicated when we graph them. So we'll talk about how to use our calculator to kind of cheat some of that tomorrow. Let's look at the next page and just make sure you can answer these 3 core questions. Okay, so these are our key questions. You should be able to answer these 3 things before you come to class tomorrow. So if you don't know the answers to these right now, go back and re-watch that part of the video so that you can answer those 3 questions.